test sound 1 2 1 2. Okay, we have sound. Looks like we are streaming. 12% CPU usage, which is perfect. Test chat. Yep. Looks like we are good. Good. I may need to lower my volume a little bit. We have music, we have chat, we have sound. Sound check, test sound. Okay, good. Welcome everyone. So we are back to the Fusion, to the Milo CAM series, or Milo V1.5 BMES P mods CAM series, something like that. I guess we need to make some kind of name for the machine, but yeah, we're good. So we are testing the new setup, the new streaming setup, the new computer actually. Not the setup, it's pretty much the same, it's just a new computer. So first, welcome everyone. Good evening, good night, good morning, good whatever. How are you guys doing today? I hope everyone is fine. I'm good, I'm happy. So the new PC looks like it's behaving properly. CPU usage is on 13%. Let me check the performance graphics. Everything looks decent in here. So I'm gonna try to keep an eye on the bitrate going out, especially since we're gonna use Fusion on this computer. Let's see if it performs as expected. I hope so. So far it's been stable, but we are only starting anyway. So yeah. So I'm gonna wait. I have some stuff to show, but I'm gonna wait, see if anyone shows up or not. So anyway, I have my whole laptop here next to me in case I need, because I'm still setting up the PC. I need to install a bunch of stuff. I think I have everything covered for today, but even so, I have it here in hand if we need. One thing I'm gonna need, it's the stock for the remaining pieces. I believe it's just, no, it's not this. What is it? Oh, it's here. So these are the pieces of stock for the what's left to do on. Let me grab a tissue, old t-shirt here to put it on top of my laptop, because I don't want to fuck anything up. So anyway, let's see. So looks like we have 3 dedicated cores for the OBS from what I'm seeing there. And I'm sending about 9 megabits per second out, which is expected. And yeah, okay, so let me start Fusion and let's see if anything stupid happens when I start Fusion. So far, no significant drop on OBS, and now I stopped seeing OBS because I have this thingy. Everything is fine. Everything looks decent. Okay, let me put this on this screen. Yeah, everything looks fine. Let's see if I open. Okay, let's transmit the. Okay, Fusion. It's like my scenes are working at least. Let's open something like my bench rest. My bench rest assembly. Uh, 2024. Maybe this one. Push Duke. And hey Joseph, how are you, my friend? So I'm opening now the. Yeah, this thing behaves perfectly. Looks like, oops, my project is a success so far. I don't see any stream drops. Well, I've seen something there, but nothing too. Yeah, looks good, looks good. So Jesus, this screen is awful for this kind of stuff. Yeah, so I'm not sure about what you mean about the ratio, but yeah, this thing it's meant to move the tower like that. Yeah, everything looks good. No stupid drops on, at least the red drops. I think I need to lower the volume a little bit more. Like that. Yeah, I like it. I like it a lot. Super steady. I get something like 10% of CPU usage. Oh yes, I'm testing the new rig. So I'm testing, I tested yesterday, but it wasn't streaming. So now it's streaming and playing with Fusion. Handles just fine. So yeah, I'm happy. I'm an happy camper with this. So yeah, I'm on screen. So yeah, I'm gonna keep an eye on it, but if you guys notice some kind of FPS drop, please tell me so I can take a look. But so far everything looks very stable. Okay. Okay, so let's close this thingy and let's go to business. Oops, did I close? Oh, okay, that's fine. What do I want? Okay, so got new stuff today. So I got this box today, which is a tool setter. As I shown in Discord, it arrived today. So this guy is, well, actually this is weird. Okay, I already don't like it, but yeah. So this is to set the tool height, and the way it works, it's basically, so you get do I have? Okay, so you get something flat, like a parallel or something, and I'm gonna use this ruler, which may or may not be very flat, and you set it like that, and you press 0, which is this one, so I'm gonna press 0. Okay, I need to hold it. There, that's zeros. Well, not, that's why you need something really flat to make sure it's zeroed properly. Yes, it has a magnetic base, but this thing it's supposed to be used manually. So what this does is, first it gives you certain Z height. So from this rectified base, so you see there's two pieces in here. There's the moving, and that's that color there. It's fixed. So I think this is 50 millimeters. At least it's supposed to be. So you know when you sit this on something, and be careful because again this is also a step here, so you need to be full base. And so it gives you that, so you know it's I think it's 50 millimeters, not sure. And then you just press with the tool until it's 0, and when it's 0, then you'll know that that the tool is at 50 millimeters from the workspace, or from the bottom. So yeah, so this has two different usage, at least for me, because my machine, since my machine I have the tool changer. When I need to set the tool offsets, I probe on this color, and then I know this thing is aligned with the color. So then after I remove my probe, because the probe it's 0 offset, so all the other tools will be relating to the probe. So yeah, when I move it there, it's gonna go, when it's 0, I know it's at the same plane as the probe, and we are fine. Hey AR, been a long time since I last seen you. Yeah, so that's why this is called a tool setter. So yeah, I don't really like it because it's gonna force me to 0 many times. But I really wanted to try a digital one, and this thing was not properly exactly sheep. But yeah, this ruler, it's also not the best thing to test. Usually we use a round pin, grounded pin, which I don't have here. But yeah. So the design, it's pretty much finished. So we are now on the fuck. Okay, it doesn't matter. On the cam side, so we are programming the machining of the parts. We should finish today. And then we're gonna go back to the micron. Finish the micron, and then we'll start building the Milo. So yeah. But yeah, I agree with you. It's been a while. It's been a lot longer than I was expecting. But it is what it is. Well, at least it comes on a nice box. This is aluminum. Aluminum. And yeah, that's everything. Well, I got some more stuff, but it's not related. Anyway, let's go to Fusion. And let's go back. So we have a few more pieces to do. Let's start with whatever comes first. So BMSP tools, Milo, functional assembly, and should be Z something. So yeah, we have the ZFF10 mount, which is the floating side, and the motor mount. Let's start with the mount. I probably I will optimize these because I'm pretty sure I can machine 2 of these pieces at once instead of doing them in one by one, but at least to check to the first prototype we're gonna do it like that. Then I will optimize it for production if needed. Okay, so we have this piece, and this piece it's a little more delicate. I'm kind of wishing to changing, because this thing is so thin, or so thin. I think I'm gonna just remove it at all. There's no point on having this thin wall here. It's gonna be kind of sharp there. So I might just remove this thing at all. What do you guys say? Leave it like that. At least it covers a little bit the bearings, but yeah, let's leave it like that. Okay, so let's go to the manufacturer side. So I saw there was some kind of update. Yeah, not in here. Probably this one is up to date already. Okay, so my stock is something like, grab the caliper. It's something like 83, not quite, but close. 82.9. Let's call it 83. And 57.5. So let's create a new setup. I'm gonna put it like that. So orientation, let's call it z-axis that, x-axis something that. Okay, I'm gonna select this, which has no chamfer. Fine. So we are good there. So we have 80 what that I said? 83, almost 84. No, actually 82, almost 83. And 77.5. Yeah, that's pretty much what I have. So yeah, we are good. We are within. We have a little more X, but that's fine. Stock top 0, stock bottom 3. So we have the 15, which is good, and we are pretty much set. Okay, so we can go back to our Y and just copy the operations. Wait, we haven't done the Y yet? I'm sure we did this one. Okay, so let's do the Y. I could swear we... Nah. Okay, let's go to the X then. I was pretty sure we did this. Let me copy these two guys to here. Okay. So, yeah, let's edit the setup. Z-axis this guy. X-axis that guy. Okay, let me grab the piece of stock for it, just to be sure we are in sync. So these are the motor mounts. Okay. So probably we have 57.5 and 82 and a little bit. Ooh. This one is bigger. Shit. Okay, I need a bigger piece of stock then. Oh, okay, this one is bigger because of the... shit. How big? So if it's 59, we have offset of 1 millimeter. So it's 57. Jesus, yeah, it should be fine, I think. Maybe not. Fuck. Fuck. 22.5. Let me check this one, since this, I think this one is a little bigger. Yes, this one, it's a couple tenths bigger. So I'm gonna use this one for the Y. Let me grab a marker. I think I can get away with it. What is my... No. Okay, I have a blue one, but I'm pretty sure I had a red one here before. Not a red one, a black one. Oh, it's there. Okay. So this one, it's gonna be the Y. And this one, it's gonna be the Z. We can tune these a little bit. Actually, let's do that. Let's tune these because these doesn't need to be like wait, nope. Let's select the model just to face edge. I need to flip that to go the other way. That. Okay, let's check if we can shave like 0.5 millimeter here somewhere. We should be able to. So how much here? It's not recommended. We only have 2.5 millimeters anyway, so let's not do that. But let me open the model. Okay. So it's this part we are talking about. So let me check if we can drop it a little lower. Okay, we can. Worst case, yeah, how much do we have from here to here? We have 1 millimeter. Yeah, we can drop 0.5 millimeter, should be fine. Worst case scenario, we might need to file this piece down a little bit just to now that I'm seeing, we don't need these things so high, so it can be thinner material. Let me see that way. Okay, it's fine like that. Let me see that one on the top, because the idea is to make them all the same. Yeah, that's fine. Okay, so let's do that. Let's drop 0.5 millimeter, because and we could shave a little bit on the bottom as well, but it's better to do it like that. Yeah, let's just drop 0.5 millimeter and we should be fine. So drop everything 0.5 millimeter on this one. So let me make sure. So we do 56.5 and everything should be fine. Let me just make sure that here, yes, I only have 2 millimeters, which is fine, kinda. It's good enough. So now I'm sure I can make it. Hey, Interside Project, how are you, my friend? Okay, so now that we did the changes, let's unprotect all of these. So face it's fine, just Control G for generate. It will generate just fine. Haha. Nice. So adaptive, I'm pretty sure it's the outside and inside, so let's do it. Oh, actually it's a 3D adaptive, so I don't even need to do anything. Just let's go for it. Boom. 2D contour, I'm pretty sure it's the outside and inside. So here and here, and let's select preferred in position in here. Okay, one thing I'm curious, it's generating the... Let me regenerate this guy, just to see if it has any impact on the frame rate or whatsoever. Nope. Steady. Not the frame rate, the bit rate. I have 0 dropped frames, which is... yeah, that's what I've been trying, testing. It's been perfect so far. Super stable. CPU usage on 10% versus 65 to 70% on my laptop. 0 dropped frames, which is absolutely awesome. So yeah, we are good. Okay, so Pocket, it's that guy there. This guy in here. Oh, okay. We need to select the pre-drill position, which is that one. Yeah. Yeah. It's all technology, but if you use it well, or for what it's supposed to be used, it will be fine. And for this, it's perfectly fine. That's why I bet on it. So, okay, so this guy, what is this guy? I'm not sure about this guy. Oh, it's the wall, finishing the wall. So let's do that. Okay, let me select the in position. Not here, in here. Preferred in position. Yeah, there, should be fine. So bores is the counter bores one. This guy is here. Okay, it's selected all the same thingy. We have the not show. Oh, you're right. You're right. You're right. Huh, okay, so I need to change something. That's weird. Because I'm streaming. Fuck. Okay, let's cancel then. Okay, I need to stream the screen instead of the fusion. So give me a second while I change that. I need to scream that guy. And okay, like that. So now it should show. Please. I wasn't watching the preview, so edit. Yeah, okay. Okay, so I'm gonna do all again. Let me Control Z the shit out of this. Even the setup. So I'm gonna do it. Yeah, okay, thank you for that. So I need to stream the screen or a window instead of I can't stream just the fusion. Okay, thank you for that. Okay, so let's do the setup once more. The dimension should be fine. Yes, I have that. Oh, okay, this one is thinner. This thing is thin. Yes, it is. Um, The others as well. No, this one it's longer. Okay. Okay. I'll need. Fuck. Okay, I need to order, or I need to check if I have 15mm stock, because this thing, I took the measurement by one. I thought they were all the same, and they are not. Okay, fine. Great. Anyway, let's move on. Okay, let me put 2.2mm. Yes, because it's 12mm stock. So this one it's fine, but those are not. Okay. Great. Great, Bruno. You're the best. Okay, so yeah, these values are fine. Okay, I'm just thinking. So I have 2.2, which is kind of low. Okay, let's do something different. Let me check the Z. Okay, this is fine for now. Give me a second. Let me check this one. Okay, so this one is thicker. And the X is also thicker, right? Yep. But this one is bigger anyway. So it doesn't really matter. It's a different piece, I think, right? Yes, it is a different piece. Hey Garrity, welcome. Thank you. Okay, so since my stock is, well, I can grab it with a 1mm jaws, or the the 1mm offset jaw. It's not ideal, but I can make it work, at least for now. I should have ordered 15mm stock, not 12. It was a miss. It was an error of mine. Well, I can make these. Well, yeah. Okay. Let's not complicate stuff. I can make this thingy a little. It's not really a good idea. Well, I can. No, fuck it. What I'm gonna do, I'm gonna order new stock, or I'm gonna pretty sure I have something I can work with this, but I'm gonna do 15mm stock instead of 12, and just get over with it. So here we're gonna go 5.2, and everything will be everything is better this way. So I'm gonna unprotect here. So these, I have these operations here because it's pretty much the same operations that I need from this piece. So I just copy everything to save some work in here. Face, I don't need to define anything, so just Control G for regenerate. The actually I need to edit this, and I'm gonna set here 58 millimeters. So my face mill is 63 millimeters, so I can deck it all in one go. Okay, it's still doing that, so let's do 60. Should be fine now. Yep, so I can deck it all in one go instead of doing 2 passes. Here it's a 3D adaptive, it's the same. It goes to machine and just check the object. So we don't need to select anything, should be fine. Let me just make sure we are under the, where's the model? Let me select the model. Okay, I need to do an inspect section from here. Just want to check if I'm going under the, doesn't cut the thingy. Okay, where is it? Fabrication, right? Utilities? Yes. Let's disable the thingy. Let me clear the stock cache. Should be... Where is it? Is it on a setup? Shit, I don't remember. Where is it? So this is a new feature, or showtime clear toolpath. Nope. I know somewhere. Oh, clear in process, clear cache. And now I can see just the toolpath. And I can see I'm getting a little lower than the model, which is exactly what I want. So I can turn on the thingy again. And I'm gonna turn off the analysis. Okay, so 2D contour, it's the main contours. So I'm gonna select that, and since again I like to start at a corner to blend in the where the cut starts and finishes. Pocket, so it's this guy, this surface here. There, clear, this guy, and let's do a pre-drill position on this guy because we have no stock there, so it can plunge there and go like that. So this one is to finish the wall of the pocket because I don't like to finish. End mills are good cutting either on a side or on a floor, but they don't really like to cut both sides at the same time. So I like to do an operation to for the floor and another for the wall. So bores are these guys. So let's select one, and since we have select all the same diameter, it's going to select them all. Now one thing we should be careful, it's this, see? it's gonna account only the cylindrical surface. And since we have a chamfer, and this is why I usually don't have the chamfers modeled, we need to change the top height to either selection, or we can go for more generic. Oh, this is different. It looks like they changed this. So I want the highest of this one. So here you can select multiple ones and it will go for the highest. In this case, we just want the model top. So we go model and top. So they changed these to buttons instead of text. And this is new. Last time we used it wasn't like that. Okay, so we are done there. So now we have some drills. Let's see. So usually I use the spot drill as... Oh, this is different as well. Avoid that thingy. This is new in here. Anyway, so I'm gonna use the spot drill as spot and chamfer. Since these drills are 5.2 millimeter, and this is a 6 millimeter spot drill or chamfer tool, I can go down to 6. Usually I only use 5.8. So that's I'm gonna do 5.8 as there. So let's select the holes, and that should be it. So if we go zoom in, yep. So as you see, we have some cut in here that is not supposed to be there according to our model, but that's it. We actually want that. We're gonna do the same for the inside ones. I make two different operations because they are two different diameters. Yes, you could do in one operation, and instead of going to a chamfer diameter, you could do a chamfer width, and it would go basically do an offset chamfer according to the drill you have. It's fine. As long as you make the math and you don't go further away than you can with your tool, should be fine. So in our case, it's a 5.2 millimeter drill. We are doing a 5.8, so that's a 0.6 difference. So it means it's a 0.3 width. So we could do to chamfer width 0.3, and then we could select these ones, and it would do the same width, but I went to the diameter instead, so I did two operations. So let me select the holes. So I'm gonna show that it could be done with just one, so I'm gonna duplicate this one, then I'm gonna delete it. So here, instead of, so here we have 5.8 again. Since we have 5.2 millimeter holes, it's, if I change here to chamfer width and 0.3, and here I could select these two as well. So it will cut that there, and fuck, I did a full spin, and that there. So, and just one operation. So it's up to you. There's another reason I usually also do 2 operations, but that's because of my laziness on my machine. Okay, so we have, I'm pretty sure it's this one. So this is a 2D chamfer. Here, since I have the chamfers modeled, I'm going to put 0 there, and I'm going to put something like 1.5 in here and 0 here. So it auto calculates the chamfer for me. If you already have the chamfers marked on your okay, so why upside do it yourself laptop on bike handle bar bracket? Huh, no idea what you mean. Welcome, by the way. Okay, so let me check the oh, okay, it's because I see. So on that particular case, since I have this big chamfer to do, but on this part it's not so big as on this one, and I copied from this one. So on this one I need a second tool to do this chamfer, but actually here we don't. So, but I'm gonna do the same. I'm gonna do the rough pass first. I'm gonna select the. We don't need this. Chamfer, select. But I'm gonna do the same. I'm gonna do. This is something like should be a 1.9. Should be a 2mm chamfer, I believe. Let me check. Actually, it's 1.5. So 1.5, it's fine. I can do it all at once. So let me add it. And yeah, since it's modeled, I actually don't need anything in here. So the thing with modeled chamfers is you can't do what I was trying to do. At least I don't know how to do it. Maybe it's possible. I'm not sure. Okay, I need to set here 0 as well. Oh. Here, let me put something like 1. So on this one, since it's a big one, I made 2 operations, like a roughing operation and then a finishing operation. And yes, I have the chamfers on in here, but when I did the programming, I turned off the chamfers and I did it manually. So when you have the chamfers modeled, at least I don't know how to do it. I haven't actually looked into it. Why is this thing? What have I done here? It's missing references. Okay, point is selected. Not sure what happened here. Something happened. Edit. Yes. Close chain changed. The fuck? No idea what happened here. Okay, I forgot to delete it. Select there to start. Anyway, I have no idea what happened there. Fusion being fusion, maybe? Okay, so... Okay, let me select the starting point. Forgot that. So I'm gonna start there. Just to blend in on the corner. And I'm gonna delete this one because we don't need it. Tool 10, so this is the 5.2 drill, right? 5.2, so let's go edit. Let's select these guys, should be fine. Let's select here to cut through, go down, perfect. Now tool 92, which should be 2.8, which is the drilling for a forming top M3. So edit. I'm going to select one. It will select everything. On the heights, it's going to go down. I want a bit more down because we're going to thread these holes. And here, let's going to edit again. And we should have the M3 tab. And select these guys, should be all fine. We should go 1 millimeter down to make sure everything is done, fine. And let's save and let's do a simulation. Milling simulation run. So it's gonna go there. It's gonna do the 3D adaptive. Gonna clear everything for us. Pocket, finish the wall, do the counter bores. Like that. Chamfers, make it beautiful. Chamfer, done. Drill, drill, tap, and boom. Everything is done. Everything is how it's supposed to be. And done. So this setup is done. So now the second part, it's going to be like that. Let's edit. So z-axis is this one, y it's like that, x it's like, actually I want to do that corner instead. So y it's the other way. Why Fusion does this to me, I have no idea. Yeah, okay, like that. So I want that bottom corner there. And the model, we want this model. And we should be fine. We have the extra stock from the previous setup. As we should, so I'm gonna unprotect everything in here. So we're gonna do Control G for generate. Okay, we're gonna add some stuff in here. Oops, yeah, fuck, I did on the wrong place, pretty sure. Yes, that's the pass extension, so I'm gonna do 32. I want it here, 60. Which is the step over. Okay, that's fine. So for spot the chamfers, we're gonna spot. So I assume these ones are for the small ones. So we just want some spotting to clean up the edges. Let me select all of them. So it's gonna do that. And here, it's just a cleanup, just a edge break chamfer, nothing fancy. I don't even need that, but I'm gonna do it anyway. It's good practice. So it's just a small edge chamfer or edge break, something like 0.3 millimeters, which is very small. Could be smaller. And yeah, that's it for this one. Let's save it. Let's copy. And let's bring it to this one, which is very similar. I'm gonna actually delete this setup and Control V. And let's reorient this thingy. So let's select the model first. Z-axis, this plane, X-axis, that guy. The other direction, because I like it like that. And the stock should be different, because here we only need 3. So you get 15 millimeters total. And 57.5, 82, these might change, but should be something like that. And let's do the same thing. So here we shouldn't need to mess with anything, just a cleanup face mill pass. Here same, since it's a 3D toolpath or a 3D adaptive toolpath. So here we need to start selecting stuff. Same story, that guy. So these are the finish parts. Preferred lead in, there to break or to blend. Pocket, close or delete. Put that guy. We need to select the pre-drill position, because on ramping we are using pre-drill. So it means we need to get in somewhere. And we get in there. 2D, so this is the finish of the parts we just machined, so the outside and the inside. There and there. We go to the preferred in position there. That. Bores, easy. Just now, since we changed the thingy to the highest and it's the model top, so it's already there. We don't need to mess with it. Now the spotting for chamfering of these guys, everything should be set. And it's set there. Same stuff for the inside ones. There. Now chamfer. So now we need pretty much only to I need that one. That one. I think I forgot that one on the other piece. Let me check. So this should be in here. Yes, I did. Oh, we need to create a setup sheet as well. Here, and yeah, I forgot this one. It's not super important, but let's be consistent. Okay, so now this one, it's actually this one, this outside chamfer, it's should be about the same. Yeah, okay, so it's the same. I can actually do it all in one op. So let me select this one as well, and since we are here, let's select the lead in. So I'm going to select here and here, just to be close, one of each other. Oh, why is it? It's probably because of the... Makes no sense though. It's one simple line. Empty toolpath, if you are machining chamfer, that's model. Okay, let me check something. Yeah, it should be fine. Oh, it's the outside one, the problem. Let me check. Ah, I see. Okay, I see. So this one, I need to do something else. I need to do an open contour and okay, let me teach him it's from this. Yeah, open contours sometimes are a bitch. Okay, I need to go like that. Actually, I don't want this piece. And what I want, it's 2mm start, 2mm end. So this will basically extend tangentially the offset. Actually, I'm gonna do it 3. And you can see the trace lines. It's gonna extend. Yeah, that should be fine. Yes, because this in here, it's actually rounded, and we're gonna do it after. So we don't need this one, but we need to round this thingy. And to round this thingy, we're gonna do a new operation. 2D. Yes, 2D, because I have a corner mill for that. So 2D counter. And I'm gonna press Alt and select this guy, so it selects just that guy. I'm gonna edit, and I'm gonna add some extensions. 5mm should work. So on the tool, let's select, I'm not sure if it's, I think it's a radius mill that I have. So yes, it's a tool line, which is a 2mm. No, actually it's not tool line. It's this one, tool 77, which is 1mm. It's the tip, so it's the diameter of the tip there. And R2 is the radius, which is 2. And yeah, that's pretty much it. I think we don't need to, I'm gonna do 2 passes. So what I'm gonna do here, I think it's multiple depths that I want. And I want to finish step down with 0.1. Yeah, it should be fine. I think it's like this. I'm not sure. Okay, it's not. I'm gonna do the easy way, which is the first one. I'm gonna give it a pass, and I'm gonna take this out. I'm gonna make it stock to leave. I'm gonna activate smoothing, which should be activated, and I'm gonna make it 0.05 like that. And on the second pass, I'm gonna remove that, and I'll just go with the single, and that way I have what I need without worrying too much. Yeah, that's about it. And now tool 10, 5.2mm drills. Hello, Antonio. Fuck. What have I done? I fucked up somewhere in here. Yeah, I don't care. Okay. I was messing with my YouTube chat and I fucked up somewhere. Doesn't matter. Okay, so all faces, it's this one, so it's the 5.2mm. It should be set to drill through, that's fine. Now the 2.8mm, which is this, boom, should be a little deeper. And it is. And tool 13, which is M3 top, edit, that. Oh, by the way, I ordered one of those fancy mills for M10 tap or M10 threading without drilling. So yeah, we'll see. Okay, we have a problem here. Oh, we don't have a problem. It's just not going through. So it's supposed to do drill tip through. Oh, okay, it's just not drilling through the, yeah, okay, that makes sense. That's fine. And we can do a simulation. Let's go. It's cold today. So first it's the face, second it's the 3D adaptive. So we are eating 10% of our CPU now. No drops at all. Finishing, finishing, boring. Chamfering. Corner rounding, which is done. And tapping. Okay, we're good. Next. Let's save. Since this one is done. Let's go to the second part. Face. Okay, let's first do the setup. So again, I like this cornering here. So let's do that. That guy. Z-axis this guy. X-axis this guy. And I don't know what Fusion has against me, but yeah. Nope, we forgot to select the model. That. Okay, we only need to regenerate the face. It should be set accordingly. The drill, it's the small screw, so we chamfer pretty much the small screws, holes there, and then we chamfer everything else. Oops. Edit, close. We chamfer that, and that, and we can, this is just a edge break, but let's keep it like that. So now if we simulate everything, so we do this first, actually it should be like that. So spotting, chamfering, rounding, drilling, tapping, removing extra stock, spotting, chamfering, and yeah, everything is pretty much done. So let's save, let's create setups. I could swear we done this, but okay, so let's put it, frame it for the picture. So setup sheet, okay, quick access, yeah, I don't have it here yet. So desktop, drawings and setups, Milo CNC here, post. Okay, doesn't show in here yet. So again, this is a problem with Fusion that I don't know if it's me, if I'm doing something wrong, but for me, what is it? Okay, yes, it's not there. this thing always saves the file with the name of our file in Fusion instead of using the setup name, which is bollocks. Okay, so we have here top or front actually. And then we have this guy. See it, if we keep the name and we do another setup, it will overwrite the first one. So I always need to come here, change the name, and do the second one. So this is supposed to be the back. I'm gonna leave it minimized. Okay, so we have the X. Now let's do the Z. Same story. Yeah, a little bit. We need to come up with some nickname for it. Setup sheet, select, let's go change. Yeah, okay. So now it's the Z, it's this guy. I blocked. So one front, and so I like to put one. It means it's the first setup, and two means the second, whatsoever. It's just a me thingy. You guys can name it whatever you guys wanted. And back. So in case of you're wondering what is a setup sheet, so a setup sheet basically, fuck, I need to redo this one. So let me delete it, because I forgot to reposition the thingy. Could be fine, but setup sheet, okay. So this basically creates an HTML file where it shows how the setup was done. So back, which I can open one in here in a minute. Okay, so basically it shows the stock size you need, where the origin point is, the part dimensions if you want. So if you don't have exactly that stock, as long as you have enough for your part, you're fine. It shows the lowest points on the work coordinate system. So this is the lower, this is the higher. The operations you're gonna make to it, the tools you're gonna need for the operations and whatsoever. So yes, I have the assembly setup. Sure, I can show you. Give me a second. Actually, I think we have it here opened. Okay, so the changes. So this is the what I call functional assembly. It's not pretty. It's not. Let me update the parts. It's just functional. So it shows everything that you need. It doesn't have the detail that those guys make, like the blocks are just blocks with kind of the shape of the blocks, the rails. You don't have the actual rails, you just have where they move. But this is not to be pretty, it's to be functional. So here I can select everything. I have all my joints working, and I can check the movement of the machine, what I need, if I need to do any changes. Like if I, as you can see here, the spindle gets way too low, too back in here, and in here it doesn't get to the front. That's also because I have a stop in here, but that's fine. This is everything you need to see to actually make sure that the machine is functional. So the changes, so pretty much I got rid of all the 3D printed parts. Yep, this is going to be all aluminum. So at least where it's needed. So you could use the 3D printed parts here on the skirts. I decided not to, and I'm gonna have two options for the. If I'm gonna sell the kits of the parts, I'm gonna have these parts as optional because you don't actually need it to be aluminum. You can get them in plastic. I prefer to go aluminum since they hold the fit, but again, it's optional. Everything else is definitely aluminum. So the changes are, we're gonna fill all these voids with epoxy granite because I'm not gonna use this thingy as a electronics box. It's a huge mistake. Well, ships flying, yeah, it's not a good idea to have the electronics in here at all, in my opinion. And it's not practical if you need to. It's just it's stupid. Let's call it what it is. It's stupid. So I'm gonna use ball screws instead of lead screws. Where can I show you? Yeah, maybe in here we can hide. Oops. So I'm gonna change the. So this plate is the plate that comes with LDO. The LDO kit. So what is changing here? I'm gonna use the same plate. I'm just gonna modify mine. I can also provide this plate if needed, but okay, ideally it can be modified. What I did is I've opened pockets in here so the screws can, so you can put the holding system under the top, and a lot more anchor points. I have no idea why they only use this thingy hold by 4 screws. Don't ask me why. It's a huge mistake. So the idea is to machine some parts in here with that fit here, and or just use plain screws to hold it down, and everywhere in here. And you see 2 hole patterns in here. The original ones are these ones, I think. Yes, these ones are the original ones, which are M5. No, they went. LDO just makes whatever they think it's fine, and since the original design it's like that, they just went with it. So I think this plate is it's well used to actually stiffen the x-axis. So the more anchor points you have, the more rigid the x-axis will be, or the table will be. As I was saying, I also added these pattern here. So these are going to be rim dolls. So they're going to be used for precision alignment. So you can just, if you need something straight, you can just put one pin in here and another pin in here, and you know you have a straight line across those pins. And for using, I'm gonna design, I already designed some vices for this thingy, and it's gonna have the same old pattern for pins, so you can just use pins and you put the vice in, and you know you are trimmed. You don't need to go with an indicator and check if it's straight or not. So you're going to be immediately trimmed. As I was saying, I changed the I'm going to use the ball screws instead of the lead screws. I'm gonna go overkill because it is what it is. This is overkill. I'm gonna go with a double nut system with a preload system, so it's an anti-backlash setup with ball screws. Completely overkill. Why? Because it's cheap. These ball screws are so cheap that I decided to go, well, if I'm spending 180, why not spend another 50 and just get some 3 more ball screws, ball nuts, and just do a anti-backlash system. It's just like that. It's because why not? It's completely optional. It would be just fine with one ball screw. Especially, I didn't knew about the quality of the ball screws I was gonna use, and I can't feel any movement at all on them, so it would be just fine with just one ball nut. But yeah, since we are going crazy, let's go full crazy. So yeah, it has a preload system in here, basically a system of actually it's better if I do analysis thingy. Let's see. Oh, we are pretty much I'm programming the parts already, so the prototype it's gonna come out pretty much middle next month. It's when I'm gonna start building my Milo or my Bruno, whatever. We need to get a name for it. We are pretty much there. Okay, let me edit. I'm gonna sell. Fuck. Displaying. So this is the system I came by. So 2 washer springs. So they call it spring discs, I believe. Belleville washers, you name it. Cup washers. So we're gonna make a spring with it. And the idea is to get shims. So I'm gonna provide the shims with the kit, so we can adjust the preload. We can go from practically 0 to whatever. AMM doesn't sound bad at all. All metal Milo. Yeah, full FMM, full metal Milo. Yeah, something like that. Would be fun. Okay, so what else? And the other thing is I'm gonna fill everything that I can with epoxy granite. As I was saying, I'm gonna fill this. I'm gonna cancel that now. Let me that. So I'm gonna fill the bottom. These corners here that we see, it's also epoxy granite. So I'm not sure if I'm gonna go down there or not, because we got another idea the other day. We might do a part, I need to think about it. We might do a bracket, some kind of a bracket here, a V bracket. So the idea would be, okay, I'm gonna capture position, something like this, do a piece like that. We can cast it from epoxy granite because it's cheap. So basically something like this. Okay, I'm fucking it up because I selected the wrong plane. So the idea is something like this. This is just a rough design. Oops. Yeah, something like this. Oh fuck, I forgot a line there. So this kind of bracket, like this. So because these plates have add stability on this direction. Bams. We'll see. But we don't have actually that something. So this thing adds stability, and I don't know why they didn't come all the way down, but that's another thing. It would be way better. But we don't have anything that gives it rigidity on this angle. So this would help a lot. Something like this would help a lot. And we can do like a 3D printer, a 3D print, casting, mold to do this. So maybe we can do something. I need to think a little bit about this, but it would help a lot. And what more? Pretty much that's it. Oh, and of course I'm using proper bearing blocks on the on the every axis for the ball screws, because it's what makes sense. And I bet you this thing also this corner here, it's very important because they only use, if we open the original Milo, so they only use the bottom piece as pretty much as the electronics enclosure, which is a mistake. Since I'm gonna fill the whole thing with epoxy granite, it's gonna become basically a rock. So it makes sense to join this C section as rigid as I can to the base, which is a block, a single block. So they only use these 3 or 6, let's say 6 brackets to use it. I'm gonna actually fill everything with epoxy granite, and since the aluminum has the slots, it's gonna create a super strong anchor, and it's gonna adhere super well to yes, it would. But I think this would be better. And easier, to be honest. What happened to my corners? Yeah, sometimes Fusion does this. Visual edges. So what more? And we're gonna use covers for the linear rails and the ball screws, because ships on the linear rails and the ball screws, it's a no-go at all. So yeah, we are thinking about this. What happened? Why I'm not seeing the preview? Now I am. So we are using, this is the first prototype, which I actually don't like very much. So these bellows. And today actually I can show it better. See, these things are traps for ships in here, and I don't like this idea. I need to check it better. I need to think better, because, and it's like that on all the corners, and I don't like that. On my machine I have this kind of stuff, but these foldings there, as you see, these things are like pockets for ships. Don't like that. No spiral, we can't use spiral in here. So I want a different design other than this. That's the thingy. Because mine, even these ones here on bottom, are the same. Mine don't have this flat, that's true. Mine are only like this, so it's like a house. And the ones on the bottom, of course they don't have these two, because it's the yeah, flat sheet would be a thing. The problem is we have to reduce it to when it's fully folded. It needs to be thin, because we don't have much space to use. And we only with this surface here, it's not easy. It's not an easy task to make it like that. I asked about that, but they can't. I believe they could if I provided the design, but it's not easy. So I'm not sure yet. This thing, it's better than nothing, that's for sure. And we can use this as a first test. But I need to, again, mine don't have the foldings like that. And what about leather? Well, it depends. We could use just a flat piece of tissue, and moving along, it would work, or it would keep most of the. But let's try to make it at least a minimal classy. And yeah, I'm pretty sure this one, it won't be the final iteration, but I need to think a little bit about it. The main problem is we don't have a lot of space. Where is the here? Because let me activate the things that are missing here, which are the table. Yeah, the table is enough. Also here, let me hide this. So this corner here, as you see it in here, it's supposed to be 3D printed parts. Nope, we're gonna epoxy granite the thing as well. We're gonna make it as rigid as we can. So this is 3 pieces, so it's a C-section here. Yeah, but I don't think they can make a fully round. Yeah, I understand what you mean. Like a half round, exactly. I don't think they make them like that. I can ask, but I'm pretty sure they don't. Because as I was saying, mine are like a house. The mines are like a house, and the foldings on the bottom like the corner, they are to the other side, so the ships actually fall. Well, they are pretty straight, but the foldings are not like these ones. So, but it's a different supplier. I need to talk with him, and I went with these guys. They were cheaper, but I don't like them, to be honest. And we need to fit it at most in this space. Actually, it should be in even less. I believe this is 50 millimeters. It should be 40, actually. It should be 40. So I'm gonna put +10. Yeah, it should be like this. We should be able to fit them in within this space. So the spindle comes like that, and even so it should be a little more, but these spindle brackets may need to change. I don't know. We'll see. According to this dimension here. I want to keep the spindle as close to the column as possible. But yeah, so some stuff it's still going, but we have time for that, and there's something that it doesn't mess with the mechanics. The only parts that may change yeah, I've seen those as well, but they don't fit in such a low space. In last case scenario, we can try to design some telescopic ones ourselves with 3D printing. I would try to avoid that because of tolerances and whatsoever. But in last case, we can try something like that. We'll see. I even seen some that are pure tissue. They are like the Windows shades, that they are spring loaded and they are roll out of the roll, and then they spring in to the, and they roll in again. But they are plain, so I don't like that. Ships can always bounce and come here. Ideally, I would like something like this, or worst case scenario, straight. We'll see. We have time until we get there. Until we get to that point, we have time. Okay, so let's go to the final pieces. So this one is done, this one is done, this one it's done, it's where we copied the stuff, this one as well. So let's go to So the Z motor mount. The Z motor mount is the more complex shape that we have because of this ramping. So how are we gonna deck it? So this thing is sick. So this thing is 32.5. So we're gonna use 33 millimeter, 35 millimeter aluminum. Yeah, we're gonna deck it in this orientation first. So manufacture, and let's do yeah, I'm thinking, yeah, let's do it like this. Let's try. Okay, so same story, new setup. Let's select Z-axis, X-axis, the other direction. Stock, let me see what we have. So yes, 35, as I was thinking. So you have something like 83-ish. And 139.5. So we can add like 0.5 millimeter more in here. And we have 140, 83. We don't want anything there. We want 2.5 on top, on bottom. And yeah, that's pretty much what we need. That's there, the body is selected. Let's go. So let's deck this with a 3D milling operation to start with. Let's just do one little change. So new operation, 3D milling, adaptive clearing. Let's go with my long, which is a tool, like 8 millimeter long mill, which has 35 millimeters flutes, so it can make a 35 millimeter cut in one pass. We're gonna go everywhere. We're just gonna keep, instead of going under the model bottom as I usually do, I'm gonna actually keep the 0.2, it's fine there. So from the bottom 0.2, that's fine. And with the stock to leave as well, it's gonna be 0.4. which is fine. Let's activate smoothing. Optimal load, I'm going to be a little more conservative since the mill is long. And maximum roughing, since this is a 32 millimeter, let's go 16.5. So 2 passes. And 1.5 millimeter fine step down. Flat area detection. That's fine. Everything else should be fine. So let's go for it. Yeah, this thing calculates at a reasonable speed. I'm happy with this computer. I really am. Okay, so we have, after 10 minutes, we have this This thing, what I'm gonna do, I'm gonna actually decrease this, or increase, I think it's increase, right? The stay down, so it doesn't do any as many retracts. Yep. Yep, like that. So these retracts are the steps. There are no way to deal with them. It should be fine. Let me see how it was before. Yeah, I'm gonna leave it like that. Yeah, that's fine. Looks good. Everything looks good. Solid. Decent. Fine. Okay, so now let's do clean up some walls. Or maybe... Yeah, let's clean up some walls first. New operation. Milling, contour. Now let's select finish. So we can start with this guy in here. So I need to, since it's not a full contour, because it has this little slot in here, it will select just one edge. We can select here, that's a closed chain, and it's gonna guess, oh, so you want this one? Well, not really. So when we do it like this, when we start indicating what we really want or something, it's gonna keep guessing more and more what we want, and this is exactly what we want. So I'm gonna go with smoothing, of course, and yeah, I completely forgot to check how to save that option. Preferred let in as usually on a corner. What else can we do? So let me check the heights. So it's going to be selected contours, which is 0.4. Yeah, it should be fine. I'm gonna put minus 0.2. I need to check something first. Okay, so I'm gonna do that contour. I'm gonna do a few more. I'm gonna do this one as well, and this one, and this one I'm gonna click again. I'm gonna make it close. Yeah, that's exactly what I want. And let's see. So okay, the machine, it's gonna machine a little lower than that, which is fine. We're gonna lower there, that's fine. We are lower there, which is also fine. Yeah, everything is fine here. I may do a little more under. So minus 0.5 should be fine. Not sure about that one, because I don't want to deck the floor. that may be too much. So let's do 3 and call it a day. Okay, so we finished that. That's fine. Oh, actually, I forgot to. We gonna face it. I completely forgot. Let's select the tool. Red Beast. Let me minimize all this stuff or close all this stuff. I only use this one. Yeah, we're gonna face everything. Doesn't matter. Doesn't add that much more time. So then we do the adaptive. It's pretty much the same. Doesn't matter, because we are not actually removing anything at first pass. Well, we are, but not for the fusion. So okay, compute everything. So now let's finish the pocket. New operation to the pocket. So let's finish this guy. Let's do we should be fine. Let me select, yes, it's finish 4.8, smoothing and stock to leave. I'm gonna leave some radial stock, and of course nothing on the floor, because the floor is what we are finishing. Yeah, we should be fine like that. It's a good strategy. Then we're gonna finish the wall. So 2D contour like that. Let's do edit. Let's add some extensions. So you see there the extensions there. So it starts a little under a little before the programmed place, and it will end a little after. Just make sure it cleans up like that. That's fine. So we clean that, we clean that, we clean the floor, we clean that as well, we clean the top. So now the only thing missing is the actual ramps. And for the ramps, we are gonna go with a ball mill. And let's do, yeah, we're gonna go with a ball mill. Let me save, just why not. Okay, so now 3D milling, and what we want is probably parallel. I think it's the best way. There's a ramp here, I'm not sure. Creates a finishing, yeah, steep areas, which is not exactly what we want. So let's try parallel first. So let's go with a big ball mill. So a mill with big balls, like this guy. 12 millimeter sounds about right. And what we want now, so they relatively not long ago, they modified these, and I'm still a little bit confused about this system. But basically, so you could select the areas that you want and whatsoever. Now it's a little different. I think it's better, but I'm not used to it yet. So the first, they start with everything green is to machine. So actually what we want to machine, it's these flats here. Well, not flats, these ramps. So what I'm gonna do is start with to avoid everything first. And then I will add what I actually want to machine, which is these two parts. And let's go from there. So I selected the mill. The heights don't really matter for now, unless we see we have a problem. And past direction we're gonna see, actually we want on this direction. Step over, I like to use 0.3 millimeters. It's not too steep, it's not too or too little. Let's activate smoothing. And for now, let's start, let's see what it gets. Hey, actually, it's exactly something like this that I want, but see, we have some extension here that we actually don't really need. And that's because of our limits, I believe. So here, no, here. Yes, we have the... So here is the boundaries. So I'm gonna select selection, and I'm gonna select these guys, and I'm just adding some offset, like 1 millimeter offset, and let's see how it goes now. Okay, now it looks much more promising. So I'm seeing here some, well, it doesn't matter if it smooths out the corner a little bit. It doesn't really matter. What we could do in this case, so to avoid this, see, it's gonna smooth out and it's probably gonna bite this top surface. Again, in our case, it doesn't really matter. This is actually only aesthetics, because we could use the whole thing just fine. It's just I think it looks better this way, because it would be fine if we had the full, if we hadn't these like chamfer. But I think it makes the part look better. It's going to increase the machining time a little bit, but who cares? So what we could do in this case to avoid that is we could go to this to our design, and we could go to surface, patch, and we can create a patch in here. No, actually we can't connect. We can make a patch in here. What we could do then is not sure if it extrude maybe. Okay, this one is nope. Let me see if it's extend then. Yeah, okay. Let's go back, let's create a sketch. Let's go the hard way. Let's create a rectangle, a bigger rectangle than this. Let's copy this rectangle to that side there. So what we want is a rectangle that's slightly bigger than our surface. Fine. Now let's create a patch from those rectangles. So now we have these two surfaces here. And now we could go to the manufacturer, and here on our operation parallel, here we would select the model, and we would exclude the original model. We would delete, actually, let me cancel, let me duplicate the setup, the operation. I'm gonna suppress this one. I'm gonna edit this one. So again, let's go to our model. We do not include the original. Let's clean all of this stuff, and we can do selection. We can select both of our thingies. We don't need the offset here because the thingy is already bigger. We do the tool center, so the limit is the tool center can't pass outside of our rectangles there. We can do rest machining, actually. It doesn't really help on our situation, but that's fine. Actually, let's deactivate it. We can delete everything here. We can add now our thingies to machine, and we should be fine like that. We should be fine. Oh, no surface. Yeah, model surfaces. Yes, we need to select the surfaces. I forgot about that. Control G. Why didn't it generate it? Okay. Why didn't you? Oh, because we have the model top as the maximum. Probably. So on heights, yes, we have stock top on top height, and so it won't machine past the stock top. So let's just do an offset of 5 millimeters so it can go up. And yeah, this way you can make sure it only machines the why is it not? The tool is fine. I'm not sure why. Oh, it's because it's cutting with that part. Okay. Okay, let's do a simulation to see. Okay, so we do the facing, we do the 3D adapter, adaptive, not adapter. We do the finishing. We do the pocketing. We do the finishing wall. And we do the cutting. We can do 2 passes. One to remove most of the, with a rough, kind of a roughing pass, which actually we could do, since it's quite a bit of so yeah, we can do that. Actually, I like this toolpath better. So Control C, Control V. Control V. Yeah. Okay, so the first one, we're gonna keep the other one like that. On the first one, you're gonna do like a 0.6 or even 1 millimeter. It can be even 1 millimeter. And we're gonna actually leave some radial. Doesn't really matter. What matters is actually the axial 1.5 0.1 0.15, something like that. So it's gonna do roughing pass first, and then it's gonna do the final pass, doing actually the cleaning. You can see how it turns out like that. So we do all the finishings, the pocket, the wall. See, it does a rough pass like that. You see there's quite a few step over. Same story there. And then do it like that. Now it's going to be a much finer pass. You see the little lines there. Our rectangles could be a little bigger. Actually, I'm a little longer. I might do that, but yeah, it's fine. So on this operation, I could do everything better and not do these surfaces, and actually machine so make the chamfering that we need to do in here with that same ball mill, and it would take just a little longer to operate. Actually, probably less than changing tools and do another. But since I want to show that we can do this chamfer with the chamfer tool, and actually it's going to look better, that's why I opted to not to do it. So let's do the chamfering now. So this is a Z, it's kind of a 3D chamfering. Well, let's call it a 2.5D chamfering because it's straight, but yeah, it's a 3D chamfering for all intents and purposes. So let's do the normal chamfering first. New operation, 2D mill, 2D chamfer. So let's start with this guy. Just an edge break. Same with this guy. Fuck. Yeah, okay. Like that. Let's do extension. Like 5 millimeters. Extend. Okay. We can do this one as well. So this is just edge break, nothing fancy. Chamfer width 0.2 millimeters. Okay, let me select the right tool for the job, so Fusion doesn't complain too much. So what we want, since we're gonna do this chamfer, we want this thing as close as that corner as possible. So let's put 0.1 millimeter here. Let's start on smoothing as usual. Everything should be fine. No problem, man. I'm gonna lose all the lead in, lead out, lead in, lead out So it will go as close as that corner as it can. So something like this, if we do a simulation, let's go, finish. So it will go like that. And let's zoom in there and see the chamfer. It's gonna go very close to that corner, which is what we want. Okay. So let's do the other chamfers. New operation to the milling chamfer. So let's do this. Actually, we could do we'll do the spotting after. Well, we'll do it before, but we move it. So let's do this. Nothing else, right? I don't care about the positioning. That's fine. Let me select something like 1.5 in here and 0 in here to make sure that it's gonna do it right. Oh, actually, I'm seeing a problem here because we haven't machined that yet. And I'm not sure. Probably I can't do these chamferings. I'm not sure if I have a big enough small end mill or a long end mill to go down there. I need to check. That. Because it's pretty long. What we can do actually, so this is what? This is too big. Okay, let me change that before we... Because these things, it's supposed to be 4 millimeters, not 5.2. Edit. It's not here. Edit. So it's on the first? Oh, it is. Yeah, so... Yeah, I'm pretty sure the motors... Let me grab a motor. I have a NEMA here, but I want to make sure with the actual... NEMA 23, sorry. I want to make sure the actual motor... I think it's a 4.8 millimeter drill, so it's definitely an M4 screw. I think. Oh, actually these ones look a little bigger. Huh. Actually these ones are M5. Let me check the original from Milo, because not everyone gonna use these same motors as I am. May need to change. Because if these are also 5, they might be. No, I don't think so. Actually, they are. Shit. So that means I'm pretty sure mine, these ones are not. Yes, they are. Why did I? Fuck. So pretty sure I need to change some stuff. Did I took the other one there? Probably, I guess. I'm pretty sure I fucked up then on, let's check. Okay, so this is fine. So this is all fine. No need to change this. So, but I'm pretty sure I need to change these and this. Let me check. Oh, actually, this one looks good, but I'm not sure. Let me check the other one. So this is the X. Okay. Let me check the cam. So it should be this one. Yeah, okay. Yeah, I fucked up here. So these ones, okay, these ones are 4.2, but these ones are supposed to be 3.6, 4.6, and this one, okay, let me, and the top, it should be M5. Okay, I'm not sure if I programmed this with or without the chamfers, but according to that sign, I presume it's without. So I'm gonna suppress this. And now, yeah, and now it doesn't complain. Okay, so that's the point. So I'm just gonna unprotect these two. I don't want to mess with the other ones. Why are you? Jesus, why is this here? Edit sketch. What's going on here? So want that connected, want this like that, want this like that. I want that on there. Coincidence. Why did my 0 run away? That's a good question. So I'm gonna actually unprotect everything. And I'm gonna generate everything again, just to be sure. This one is fine, but this one is fucked up somehow. Okay, so that's fine, that's fine, that's fine. It's fine. Okay, so this one, it's supposed to be select supposed to be the 4.6. Like that, I believe. Yep. And this one is supposed to be the T11. I believe. I think it's T11. Yep, M5 tap, T11, boom, go. That's fine. I'm not gonna mess with the setup sheet because I don't really care. As long as the... so this is the Y motor mount. So Y motor mount bottom. Let's check the... yeah, it's fine. And I'm gonna follow the tools that the machine asks me for, so I don't need to actually fuck with the setup sheet. I'm good with that. Oh, but fuck, the setup is wrong. Okay, let me check. Yeah, it's wrong because I selected the... yeah, okay. Hey, questionable, how are you, my friend? Okay, I'm gonna do some edit in here. Edit sketch. Late. Nah, you're good. You're just in time. You're just in time. Let me see. Nope, it's not this one. Come on. Fusion hates me sometimes. I want this one. Where are the damn... oh, okay. Who cares about this point? Care about that point. Oh, okay. Go there. So what I really want, it's not actually in here, it's actually in here. Coincidence? And this one with that one. Yeah, that's what I want. That's what I want. And yeah, that's exactly what I want. So Control G, everything should be fine now. Yep. We have our origin point there. We have the right topping. Boom, we are good. So what next? Next we need to do the same for the X. Oops, I need to change something. So Y motor mount. So I'm going to protect this. Everything else should be, that doesn't matter. Protect it as well. No, 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 no. Nope. Design. I'm going to disable and I'm going to unsuppress the chamferings. So we make it beautiful again. I know. But we are good now. That's probably why the thingy got lost again. So here we're gonna do the same. I'm gonna disable the features. I'm gonna actually activate these guys, and I can go to manufacture. So you have the thingy on the right position. Oh, let me check if I have this thingy to the... Yeah, fuck it. Probably I don't have it on the other one as well. Let me check. This guy. Edit. Yes. To chamfer 5. Yeah, it should be more. Yeah, but now it's complaining because I don't have an axis. Why is it complaining? What's missing? What do you care? It's fine. Yeah, that's fine. Protect. Done. Okay, so first is this thingy needs to be more. 5.4, something like that. This thingy it's fine to whatever it is. 5, yeah, that's fine. This thingy, it needs to be the 90. The 90. Yep, fine. Yep. And this thingy needs to be the 11. This thing needs to be the 11, which is the M5. That's fine. I'm gonna protect everything. Design, and I'm gonna unsuppress again. So everything is beautiful now. Again. Yeah, that's fine. And okay, let's go back to this one. So, as I was saying, I'm not sure, I'm pretty sure my long end mill doesn't have that much travel. I could do 2 drills. Let me check my... I think I have the right... So let me do something like adaptive clearing. So my 214, which is this guy. Oh, actually, no, it's not long enough. It's 32 millimeters. Well, it's not long enough, but it's long enough for what we need, at least. Yeah, it's long enough for us at least to make the chamfers. So yeah, let's do it. It's gonna be like a kind of a waste of time, but yeah. Okay, so we need to machine these and these and these and these. but not that much, only something like selection these -3 or even, yeah, 3, it's fine. So what I'm doing is I'm just limiting the bottom height to that face -3, so it's going to be just machining 3 millimeters depth, and yeah, that's fine. Smoothing, since it's a very long, I'm gonna do a very long and it's a 3 millimeter mill, so I'm gonna be very gentle with it. That's fine. Everything here should be fine. Oh, yeah. And let's edit the top height. Doesn't need to be the stock, can be this, because everything is machined till there. So yeah, we can do this before the chamfering. So when we do the chamfering, the pockets are already there, even that they are with some wall. But yeah, we can do that. That will work much better. So I forgot to do, let's do the chamfers or the spots here and for those guys as well. Let's do that. New operation to drill. That tool. Let's do spot. The faces, we want these and these, and let's select them all. Fine. So the whole top, it's fine. The whole bottom, it's gonna be a chamfer width. Let's use that trick now. So 5.2, 0.3. Why 0.3? So I like to do just at maximum 5.8 on a 6 millimeter spot drill. Even that in theory it can do 3 mil, but I like to do maximum 5.8. Since the drills are 5.2, so 5.8 minus 5.2, it leaves 0.6. And since this is a chamfer width, it means it's like a radius. So we need to divide the 0.6 by 3, by 2, and we get 0.3. So that's fine, and I like to do dwell. So it should chamfer like that, just fine, everything. And we're gonna do this first. Because, why first? Because I use a lower RPM on the spotting, so it takes less time for the spindle to accelerate to that speed, or to that rotation speed, and then it will accelerate more to do the rest of the chamfers. So that's the only reason why. So I think I've done all the chamfers, right? Except the, oh no, we are missing one. We are missing, so in here we can also do this one. So what we're gonna do, I mean this one, which is straight. So we're gonna select that one, and we're gonna actually do some extensions. 3 millimeters should be fine. Okay, let's do a simulation to make sure everything is where it should. No issues found, which is always a good sign. So let's do, that's the 3D adaptive. So this is the wall finishing, floor finishing, wall pocket finishing, roughing the ramps, finishing the ramps, do the slots there, fine. Spots there. Go there. And there, and there, and there. Everything like it should be. So now how we gonna do this thing? So we're gonna use a toolpath called trace. So new 3D, actually it's a 2D milling operation, which is trace. Trace, it will basically will trace whatever you tell it to trace. So we're gonna select this line, and for this we need actually to have the I think we need to have the chamfers modeled, I think. Not sure. Actually we want it there and there as well. We can do on this case an end extension. I'm pretty sure we can do a here. Well, we can try a 0.5, something like this, just a little small one, since it's lifting. We'll see. And let's do now the other side. Okay, it selected everything as we should. Since we're gonna start in here, this one it's the other way around. We're gonna go a big one on the first, and a little bit just on the finish. And now let's keep it like that for now. Now it's gonna detect the that we are doing a chamfer automatically. I don't really remember. This is not something I do often. I did a couple days ago on one of my parts, and we're gonna see if we need to go check. I'm gonna do a 0.5 millimeters here. I'm not gonna put anything in there for now. Let's see what it says. Okay. Let me try 1.5 just to see if anything changes there. It doesn't. What if I put here a 0.5? Ah. Okay, let me check. I don't really remember. Took me a while to actually dial this one in. So let me check. I'm pretty sure I did this on my... Where did I... Where have I done it? Let me think. Oh, I remember. Actually, it's on that same project. Milo. Okay, let me check, because these I can't really show these yet. So let me change the my ugly face. Yeah, okay. So where is it? design, so it should be where? Not here, should be in here. It should be there. Well, actually, it's probably here as well. Moving shore. This one. That one. Let me remove the washers. Yes. Okay. So this one should be on the top side. This one. Okay. Yeah, everything is as it should. Okay. Everything is as it should, I think. So why it's not working? Okay. Maybe I need to do one at a time. Okay, let me try with just one first. That one. Okay, let me cancel. I just want to check what's the size. So 0.8, so it means it's a 0.5 millimeter chamfer, which is fine. So what am I doing wrong? So I'm selecting the right contour, the right tool, right? Yes. Should be center here, sync. Let me check if I need to do any axial offset. I don't think so. Wait. Why do I have so many? I don't want that. I don't want that. I only want that. Okay, give me another minute to check something else. Oh, okay, I need left. Okay. It's not center. It's not center compensation. That's the problem. That's the problem. Okay, so let me Control Z just to get the second one again. And so we have the two contours that we want. Yeah, this one should be left. So it goes like that and it goes like that. Exactly. That's the point. That's it, I think. Let's do okay, that's a little bit too much. Maybe it's 0. Oh, since it's yeah, since it's modeled, it should be actually 0. Yes, CNC, exactly. So let's do a simulation. Let's do a simulation to see, but looks good, looks kind of good. May not be perfect, but we'll see. Let's see how it goes. It has some kind of, the flute isn't long enough because it's giving that mistake because the flute, it's only 3 millimeters. And it's detecting that the Z change is a lot more than 3. That's why it's giving out the error, the caution, not an error. But that's fine. So we do that, we do that, we do that. Everything is fine so far. We do the small pockets there. We do that. Let's make it a little slower so we can actually, okay, so now it's gonna do the thingies there. Now it's gonna go there, it's gonna machine there, and it's gonna go there. See, it's detecting it's crashing, but it's not really crashing. There. Go. Oops. There. And it looks fine actually. Let me delete the model. Looks good. And yeah, that's it for this side. We can do the drilling, but it's better to do the other way. On the other side, actually we can do these big ones. Let's do the big ones. Let me activate the model again. So let's do drilling. Well, actually, we don't need to spot these ones because they're gonna be on the other side and I'm not gonna drill the whole thing. No need. So I'm gonna delete the spots there. So spot, let's delete the small ones. So just unselect these and it's fine. And we can do drilling. Drill these guys. So it's what? I don't remember. I don't remember. It's a tool 10. Which one is the 5.2 millimeters? I need to check. Cancel. Let me close this guy. We don't need it anymore. Don't save. So functional. Let me open something that has those are this one has. And now that I have that document open, I don't even need to check, because when I go here, oh no, not here. When I go new operation, drilling, drill, when I'm gonna select, I have access to the tools that we are using on the other documents, and yeah, it's a tool 10. So I can go there. I can select directly there, that tool. since it's the same project, it's fine. That one all the same. Let's do drill through 1 mil. Make sure we go down the thingy. And yeah, that's it for this side. Now we can do the other side. Everything is fine. So new setup. I'm gonna keep everything except the origin. I'm gonna go to the model box point as I usually do, that guy. So it's the corner of the model which is sitting on the parallels. The body is selected, there's no need, it's only one. Okay, so first, same story. Let's do the face milling. Fine. So when you don't select a tool, oh, actually, I need to do multiple depths. Maximum 1 millimeter finishing step, 0.2 millimeters. Let's use even. Why not? Boom. Like that. So after that, what do we need to use? This is what? 5 millimeters, fine. Okay, so what do we need here? I'm gonna do what I'm gonna do is what? I'm seeing a problem now that I haven't seen before. Let me check just one thing. How much is there? Oh shit. Yeah, it will be fine. I'm gonna use something in here. Yeah, it's fine. So I was thinking how I'm gonna do this setup here, since I have these thingies. So the vise is gonna have a hard time grabbing to these angled positions, but we can use like a 1, 2, 3 block in here, in the middle. How much is that? From there to there, or 2, if needed, just to make force on that. And it's just a couple of holes with threads, so it's just fine. So it's fine, we can manage. Anyway, so we're doing that. Then we're doing this pocket in here. New operation to the milling. I'm gonna use adaptive clearing, not with that tool, of course. So now I can use my regular 8 mil rough, and I'm gonna select this pocket in here, but we need to finish the line. Needs to be a closed loop, something like that. It's not gonna mess with this, but yeah, I think we can do that. Okay, we're gonna go smooth 2.5. And ramp, we can go plunge or pre-drill. Pre-drill, it's important. And we're gonna select these, all that. Why is it not detecting? Oh, because I want these. Want the pre-drill, not preferred leading. So select that circle, because this thing should be machined from the previous setup, right? When we do this guy, so it's gonna go down there, and actually I'm not sure if it's gonna go down there. Probably it won't. Let's check. We can simulate both. I could make it go. Yeah, it's not. Oh, but it's just a little cover. It's fine. Yeah, it's fine. So it's just a little cover. Super fine. No problems. And is it doing... Yes, axial to leave whatsoever. Everything is fine. Smoothing, fine. Actually, it's doing a little bit of that guy, which is cool. Okay, so now we need to do... So we do that adaptive. We don't care about that. We can do just the chamfer. It will rip through that little thing in a second. What else we can do? So after that, we need to do this pocket and finish the wall as well. Let's do that. So first let's do the pocket. The pocket is going to be tricky. What I'm going to do, I'm going to select the surface here and smoothing on. Radial 0.1, axial none. Let me select, I want to finish speeds. And a ramp, I don't want a ramp. I want a plunge, or I want a pre-drill, and we're going to select the pre-drill position again. Just one. And let's see. So I'm going to simulate this thingy because I don't really trust it. Let's see if it looks good. I think so. So facing, yes, it looks like plunging, but it's not. It's just killing that little cover there. Why is it not showing? Give me a second. Oops. So the adaptive. Where is oh, okay. I need to, okay. The adaptive is too low because I'm going down there to that chamfer, which I didn't realize. I need to delete that thing anyway. So we need to do selection and select this level. Now we're talking. And then it's going there. Okay, fine. So let's go again, let's simulate. So it does the thingy, it does the thingy. Now it looks like it's making a fancy, but remember this thing is hollow. It's not here anymore. And goes there and finish there. That's cool. I should delete the chamfers. I should delete the chamfers on this setup. So I'm gonna delete this guy for good because we finished it. I'm gonna protect this. God damn, it's cold. I'm gonna go to the design and I'm gonna delete the chamfers. Suppress for now. Then I'm gonna go back to manufacturer. It should be fine. There's no... Well, actually, here might be a problem. Let's see. So generate this one, should be fine. This one, yeah, this one is a problem already. Yes. Okay. It's a closed chain. But it's not that one, it's this one. Yeah, that's fine. Now, since we don't have the chamfer, it would be fine with the level. Oh, and we need to select, yes, this one. Yes. And this one should be a problem as well. Let's select, that's fine. That's fine. Oh, it doesn't know the pre-drill position, which is this one. And yes, we are good now. That's fine. Perfectly fine. So this thing is gone already. We finish it on the other side. So it's gone. So now what we need to do, we need to drill this. So counterbore this, which is what we're gonna do next. New operation, 2D milling bore, 2D milling bore. And let's go with the long 6mm mill. This one. Finish. Next. So bore, 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 and bore. I think we are good. Let me check how long is it. Oh, actually it's 26.5. Okay, so let me do two things here. I'm gonna duplicate. I'm gonna do a first bore, just the first. So on levels, I'm gonna, instead of all bottom, I'm gonna go all top, and I'm gonna give it an offset of -5, not 0.55 actually. And I'm gonna, on stock to leave, I'm gonna leave a negative -0.15. This means it's gonna make the hole 0.15 millimeters bigger, as you see here. First. Then on this one, I'm gonna actually start, instead of the whole top, we're gonna do offset -4.5, since we finished the first 5 millimeters already. And it's gonna do just the regular one. And also what I'm, yeah, well, like that should be fine. So yeah, we're gonna get a little step on the thingies, but at least we won't be rubbing. It would be just a little bit, so it would be fine. Since it's a 25 millimeter and with the bore, it's actually not that much. Actually, we can. I'm not sure why we have such a long. So we have 6 millimeters. yeah, we can use something like M520s. Yeah, we're gonna leave it like that. But if we don't go as that deep, so instead of +6, let's do +8. We should be fine, and we don't need this, we don't have this problem anyway. Yeah, okay, let's do that. Let's leave it like that. It's gonna be all the same. And we're gonna get rid of this one, and this one can be 0, and it's all good now. What's going on? What's going on with this? Why is... Never mind, I don't know, something happened here. Okay, we are good now. Everything is fine. So we have those done. So now we have to do these little ones and these ones. So I'm gonna use a 4mm drill mill for those. So let's start with these ones. So these ones I'm just gonna slot through them. Red Beast, tool 6, slot. I'm gonna select one of the sides, that one and that one. I'm gonna select both, and I'm gonna align the extensions, do something like 4mm extension. And what I'm gonna do next is actually do stock to leave, radial stock 0.5 and axial stock 0.2. And these will slot through the basically through the middle of the thingy and leave a little bit of room of stock on both sides. Now I'm gonna go again with a new milling operation to the counter, and now I'm gonna go both ways, there and there. Same, I'm gonna edit the extensions, align the extensions. Gonna do 4mm, fine. Now there's no stock to leave, smoothing on. Even there's no point because it's straight operation. There's nothing to smooth. But yep, that's pretty much it. And it's gonna finish them. Now we're gonna do the those thingies. So usually I do adaptives on these thingies, but other way to do these slots, it's actually do a 2D milling contour. We're gonna select the bottom contour. Like that. And instead of, so on selected contour, so on bottom 8, we're gonna give it a little more, so -0.5 to make sure we go under it. In the trick here, let's activate smoothing. So what's the point in here? So a counter, usually it's just a counter, right? You go, you plunge, you counter, and you go out. So, but in this case, we're gonna do another thing. So we're gonna go to the linking. Let's try with these lead-ins. If they don't work, we're gonna change them for a little lower, and we're gonna activate ramp. And here we're gonna go with the finish. Yeah, that's fine. And here we're gonna select something like, so in this case we have a very small contour or loop or whatever, so it doesn't really matter. But if you have a really long one, you really want to be careful with this maximum ramp step, because it's a 2-degree steep. So what it means, instead of going down and doing the thing, it means it's going ramp down like a spiral, but according to the contour you're selecting. So in this case, since we are doing completely drilling through solid material, it's not like a finishing strategy or whatever. What we want to do is make sure it's not gonna get more than like 1.5 millimeters, maybe should be fine. Pre-drill positions, we don't have them. And what we want also do, it's in here, it's actually do a multiple finish pass. We just put that and 0.1. So what it does, it's gonna finish. Okay, we can, okay, let me edit. So the top height, we're gonna do selection and select the top of the part, because everything else is machined already. No point of going from the beginning of the stock. We can also decrease this amount a little bit. So this is on the linking. See, ramp clearance helix. So this is pretty much where it's gonna start ramping. So it's gonna be 2.5 millimeters on top of the what we machined already. We can do 0.5. And there you go. It's gonna start much lower. And it's gonna do a finishing pass there. That's the when we set multiple finishing passes. That's what it's gonna do. So it's gonna ramp inside, and then when it goes to the full bottom, it's gonna make a cleaning pass. So that's exactly what we want. And we can do a simulation to see where we are, but I'm pretty sure we only need now to do the chamferings, and we should be done, and the drillings. So this part we are done with it already, so we can rush in through it. Actually, I'm very happy with this PC. It's rushing in through the simulations just fine. No frame drops at all. So again, that's just a little cover there, a little thingy. It's gonna do the pocket. Did we finish? Okay, we are missing one operation in here. We are missing the finishing of the wall, so we need to do that. This is watching the simulation and have multiple colors for the did fusion blocked? Yeah. This sometimes happens, even on my computer happens, so let's see if it catch up or if it blows up. One of the two will happen. ketchup, fine. So that's the slotting, that's the finishing. So the purpose of these slots is just so we have access to the poly screws. So there's the ramping thingy. So I was saying the have multiple colors on the simulation, it's good. So you know that I usually do one operation for the flooring and another one for the wall. And here we can see we have both the floor and the wall at the same color. So it means that we missed one. Okay, yeah. Otherwise we are good. So let's do the floor, the finishing of that wall, to the milling, to the counter. So let's select the 8 mil, finish, select. Geometry, we just need to select this thing. So here we need to be very careful. I'm actually gonna go, so smoothing. Stock to leave, I'm gonna leave a little bit of floor and none on the wall. Here I'm gonna go with, so horizontal, yeah, this one I want, but that's pretty much all I want. I don't want anything else. I want the smaller leading I can, and even so, might be a little dangerous. So maybe actually I want instead of a 0.8, something like a 0.2. Yeah, that looks much better. So let me put that thing there. And even then, I think we're gonna... Yeah, we'll see. Should be fine. Well, we can finish it with yeah, we can finish it with a 6mm instead. So yeah, we can do that. We can finish it with this guy instead. Finish. And we can do it after the boring. And that way we are pretty much safe. I can actually increase that value to the 0.8. Here I can go to 0.8, and I'm going to increase this value as well to 0.1, just to be sure I'm out of the floor. And that way we should be fine. Okay, so now, so we made those drills already, which I'm not sure if it was wise. But yeah, they are done, doesn't matter. So now, let's do the chamfer. New operation, to the milling, to the chamfer. So we can do all of these in one go. Then this one, 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 this one. Actually we can't, because this one it's supposed to be a big one, the outside one, right? Okay, so let me delete it. So what we're gonna do the smaller ones instead. So this can come till here, like that. We can do 2 millimeters extension, and this one, it's gonna be here, same story, 2 millimeters. So again, what I do to select the, instead of selecting the whole thing, is press the Alt key to select just one piece of the chain instead of the whole contour. So you select the whole, then you click it again to edit, and then when you select, usually you select the other side that you want, and it will fill in. Okay, and we want also that one and that one. So this is just something like 0.5 millimeters, should be fine. So let's select the tool. I haven't yet. That guy, chamfer. I should have done that one first, but we'll do it after. That's fine. So now, since we have that little guy there and we want it to go as close as we can, so we're gonna put one in here, and here we're gonna go with 0.5, and we should be good. Yes, I was afraid we couldn't machine these ones with these settings, but we can, so we are good. And see, we are getting pretty close to there. So let me do, what's that? Oh, it's probably the lead out. Yes, it's complaining about the lead out because we don't have space on the on somewhere, probably there, or on these thingies. Doesn't matter. It made whatever everything we wanted. Yeah, it's probably here. Probably it's too much to so it will hit that side. So we can go here and put a little less, something like 0.2 should be fine. We don't need 0.6, and it doesn't complain anymore. We just need to move out of the exact position. Can be some vibration when pulling up the z-axis. So we're good. So let's do the spotting for the threading. So drill, spot drill, let me select spot that. I'm gonna select here dwell before I forget. Now I'm gonna select all the same, and we want the all top through the chamfer diameter. So these are supposed to be M4s. So let's go to 4.5, 4.6 maybe. It's fine. I think they are M4s. Yes, they are. And let me move it first because I like to spot first. Okay, so now let me check if the what's the size of that chamfer that we suppressed. Configure, I believe. Fuck, no. I need actually, fuck, close. So I need actually to unsuppress it, to check it. So it's a 2 millimeter chamfer. A 2 millimeter chamfer. I think I can make it with the same tool. Problem is I use my tool very long because sometimes I need to reach very deep stuff. Ideally, I should have two tools for chamfering, one for spotting and one for chamfering, but I don't. I could set up another one, but yeah, fuck it. So what I'm gonna do, I'm gonna do two passes. Should be able to make it work. And if I see it's too ugly, I can always do another pass with the bigger chamfer tool. Or I can just go with the big chamfer tool and do it in one go. I can do that either. Or as well. So yeah, I'm gonna do that because I don't want to risk it. So yeah, it's one more tool change, but fuck it. It's the tool 25 if I remember. Yes, tool 25. Which is this big ass chamfer. And chamfer, that's fine. And again, I'm gonna press Alt. So I'm gonna select just this branch. Then I'm gonna press it again so I can edit the branch. And then I'm gonna select the end. So it's gonna go there and there. And we can do some extensions, like 1 millimeter or 2 millimeter even, that's fine. And press OK, so it finished one. I'm gonna do the same again in here. Boom, and press it again. So it's gonna edit it, and I'm gonna press the finish. Extensions, enter, done. And a 2 millimeter chamfer with a 12 millimeter, it's gonna work just fine. So no point on doing two passes. Chamfer with 2. Yeah, we can work with that. Should be all fine. And I think we are done, right? Let's do a simulation of everything. Yeah, it says it found issues, but the issues are those the trace chamfers, so the 3D chamfer thingy. That, the drills go the other way. That. So it's simulating all the borings, which actually, all the ramping actually messes up with the CPU, the simulation processor. So usually when you skip it, it takes a little bit to actually process those thingies. Especially sometimes on the Fusion. Even the... Okay, it went. So I'm using 8 gigs of RAM, which I'm using 27% of my RAM. So yeah, we're good. Those 64 gigs. The PC is performing amazingly well. I don't see a difference on my main computer and this one, to be honest. Messing with Fusion and whatsoever. So I'm super happy with it. Fusion itself sometimes has this kind of stuff, and actually haven't crashed any time yet. And even on my PC, the Fusion sometimes just crash. And so far, I couldn't be happier, to be honest. It's performing well beyond what I was expecting. I was expecting some kind of conflicts or compatibility issues, maybe some blue screens because of the origin of the chipset. But I couldn't be happier, to be honest. I'm being really honest. This thing is performing super well. way, way better than I was expecting. I was really sketchy about the. See, it's a very long chamfer tool. This is actually how I have it set. So yeah, it vibrates a little bit. And it's super cold right now, so it's kinda hard to evaluate the performing of the cooler because it's cold. It's freaking cold. Let me check. It's 10 degrees Celsius on my shop now, and let me see the sensors. The CPU is at 15 degrees. The most the heat the core with highest so the case is at 15. Is being at maximum at 22. The cores are actually the most. The other one, it's at 16 degrees. So yeah. Again, it's very cold in here, so it's kind of hard. I'll tell you in the summer. But yeah, I'm super happy. Well, how is the graphics card? Where is the graphics card? Dim, Smart. Where is the GPU? The GPU, yeah, the GPU is at 35 degrees. So we're good. Anyway, so this thing looks like it's done. And yeah, it's time to finish. It's 1 a.m. So we are missing only a few small parts. I'm not gonna lose your time or mine doing another stream, just doing, because the only thing missing is the sensors. So I'm gonna finish this. I'm gonna save it. So the only thing missing is the sensors and the not the sensors, well, what will trigger the sensor triggers. And oh, actually we are missing one operation here, so we need to finish that. So let's do that. So we need to, oh no, actually we are missing more than one. So we need to drill those holes, which we haven't. Let's do that. So these are M4, so I don't remember. I think it's the 92, 91. I think it's a 91. I'm gonna see right after. So same face. I'm gonna drill them. No need to drill all the way. So from all top to the bottom, we're gonna go like 12 millimeters, minus 12. I lost my mouse. Where's my mouse? Drill through, fine. And even 12. I need to check the length of my tool. Yeah, it should be fine. Pretty sure it has something like 30 millimeters. And now we need to go another drill. It's not actually a drill, it's going to be a tap. And it's going to be tool 12 and 4. Same diameter. And we're going to go all top minus 10. 10 millimeters, it's more than enough. Well, that's it. This system, well, for the price, I think is awesome. It's freaking awesome, to be honest. For the price, I don't think I could be better. Yeah, and I went all the way up with it. There's no way you need 64 gigs of RAM, so 32 will do just fine. If you go crazy, if you want to go crazy, like I never had more than 32. That's what I went with 64 on this one because it's so cheap, man. So yeah, I don't care. 30 bucks for 35 bucks or 33. I think it was 35. It was 33 actually dollars for such a low for 32 gigs. It's like a dollar for a gig of RAM, literally. So $33 for 32 gigs of RAM. Let's say $1 it's for the boxes. The little plastic boxes where the RAM came in. They have to be paid. So yeah, it was crazy. I'm super happy. I'm not sure how long I'll be happy, but so far I couldn't be happier. Yeah, I think we are good here. Let me check. Yeah, we are good. Okay, so now we only need one setup for the top. So this is where we're gonna put a sensor, a home sensor or a home switch or whatever you want to call it. It's actually a switch. A sensor should be, to be considered a sensor, it would need to be analog, so detect, sense multiple stuff. In this case, it's a switch because it's just an on-off thingy. So we're gonna do another setup. I'm gonna remove, well, it doesn't really matter. So model orientation, this is gonna be the Z-axis, this is gonna be the X-axis. And I'm gonna put it exactly on this orientation, but I'm gonna do the box model, that point there. So I'm gonna probe the front, I'm gonna probe the top, I'm gonna probe the side. And we should be fine like that. The body is fine. So the only thing we need is actually a spot. New operation, drilling, drill. So we're gonna do a spot. Tool, spot, that's fine. Gonna select, same diameter. Heights, same story. I'm gonna go to chamfer diameter. So these are M3, so I'm gonna go to 3.5. 3.6 maybe, that's fine. There. Yeah, it looks like a big ass chamfer because it's detecting some stock on the top, which we don't have anymore. Now we're gonna do the drilling. Drill. So here it should be the 93, which is the 2.8, I believe. No, it's probably the 92. I need to check that. I'm gonna check that in a minute. We don't need these to be super long drills or deep. So all top, I'm gonna do -10. That's perfectly fine. Yeah, we can go all the way in at once. Yeah, maybe not. Full retract. Let's go with 3mm specs. And now new operation, drill. Actually, it's going to be a tap, which is the tool 13 and 3 tap. That's fine. Let's select the geometry. Fine. And let's go all bottom, all top, -8. Fine. And that's done. Pretty much done. Now let me just check. Where do I have? Or where do we have? So on the motor mount, yeah, we can go there and there. So here we have this one. So this one should be here. No, actually it should be here. So we have tool 12 and tool 91. So 91 is the force. So let's check. So the force, yeah, 91, that's fine, and 12. And here, yeah, 92 is the 2.8, and 92, it's there. Okay, that's fine. Everything is fine. So yeah, we just need to do the setup sheet for this thingy. And we are finished. So let me close all the other ones. No, we don't need to save this. Okay, so setup sheet for that one. Post for picture. Setup sheet, create folder. Now Milo CNC. So this is the Z motor mount. So actually this is not the Z motor mount. Well, actually it is. One top. Actually it's the bottom, but because these will be facing down. So this is the bottom. This is actually the top. Setup sheet. Select. Post. So this guy, it's actually 2. It's the top actually. And this guy, so we're gonna hold it like that on a vise. Setup sheet. Select. That fucking closed it again. It's gonna be the front. 3 front. Yep, it's the front actually. And yeah, that's it for today. And as I said, I'm not gonna bother unless I find, but no, there's no point. It's simple stuff. I'm gonna machine a bunch of them together as much as I can handle on my vise, because we're gonna need a bunch. We only need 3, but it takes me the same time, just more stock, or pretty much the same time doing, as long as I can hold on my vise. Well, it won't be as many. What's the size of this thingy? This thing is small. This just looks... Oh, it's not that small. Yeah, it's small. 20 mils. So I need to machine them on this orientation. These things are 8 millimeters. So I'm gonna machine them at well, actually this is, well, let's do it as well, fuck it, because I'm gonna do something cool with this. So it's gonna be in a minute anyway. So let me Control C, Control V. Let's see, 35. How much? Yeah, that's more than enough actually. Move. So I'm gonna use a 4 millimeter mill to mill these guys. So that's fine. So from here to here, we have 34. So Control C, Control V. Let's move it 34. How much do we have like that? Oh, we already have 96, so I can only do one more. So there's no point doing one more. Yeah, it is. Maybe I can do 2. Let's see, Control V. Now I need to go 68 actually, right? Let me see. 164, but what really matters, it's not actually to there. It's actually to from here to here. Yeah, we're good. I can make this work. I can make 5 work. Okay, so manufacturer. I'm gonna select everything, of course. In this case, doesn't really matter if we do a 3D or a 2D adaptive. A 3D it's going to be faster, but I'm not sure if it's going to be. Let's try it. So first the face, of course. I'm not even doing the face. I'm not even doing the face. So 2D milling, 3D milling, adaptive clearing. It would be nice if I could make them with 7 millimeters instead of. Can I? Maybe I can. Maybe I can. Let me disable these thingies. Let me save. Where is the... Let's update. I'm pretty sure I can, because these thingies... So these things are... have the sensor on the middle, I think. Let me grab one. Yes, they are on the middle. So yeah, that's pretty far from the middle, so we are good. No need. Let me check all the other ones to make sure that... So this one... Yeah, same story. We have some flying stuff in here. Yeah, in this one it could be even lower. So yeah. So we are good. Yeah, we can do that. We can do that. Okay, let me close this guy. Let me do that. So this way it's better to use 10mm stock. So manufacturer, edit. I'm not really sure. I'm gonna put here 2mm and here 0 and here 3. So I'm not sure if I'm gonna use 23mm stock or whatever. I need to check what I have, but it's gonna be fine for now. I'll only need to do the thingy, the change if I need to. Okay, so new operation. I'm gonna do the 3D milling adaptive thingy. I'm gonna use my tool 6, which is the 4mm rough speeds. Fine. Here we are good. I'm gonna go under actually a point 3 or 4. 3 is fine. 4. Under the model, because we're gonna leave 0.2 flat detection, maximum roughing, that's fine. Smoothing, everything should be fine. Let's fire it up. So in 4 minutes, we get all the stuff roughed. Let's do new operation. Let's do facing. And yes, let's face with a 4 millimeters. But we're gonna select just the things we need to face. And I need to select the finish and the step over, something like 3.5. Pass extension, that's fine. Let's go. Boom. Everything faced. Now let's do floor finishing. So to the pocket. Let's finish. Let's select the thingies like that. Fuck. Edit. Axial 0. Stock to leave 0.1. Smoothing. And actually let's cut both ways. Let me check just step over. Maximum step over, fuck that, 3.5. Like that. And we have the floor finished. Now let's do the finish. Okay, let's do the wall finish first. 2D milling, 2D counter. Select that, 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 and that. Everything should be fine. Let's just do the stock to leave and smoothing. So radial stock 0, axial stock 0.05, and that's fine. Now let's do the finish of the actual pieces. So what we're gonna do is 2D milling, 2D counter. So select, fuck, I pressed the Alt by mistake, sorry. So let's select that, select that, 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 and that. Now let's select the enter positions. Can be this one. Just fine. Nothing new so far. That's pretty much done. I want to make sure I'm gonna go under. Minus point, actually it should be 0.2. And now I'm gonna simulate to make sure it's all good. What I want to check if my finishing is actually rubbing the floor or not. Hey, I'm missing one. Fuck, I missed one. I missed this one. Yep, I forgot that one. So here, and yeah, but I selected the entering point already. There we go. So now the different thing that I'm gonna do, well, actually let's do these slots. I'm gonna do a 2mm mill and do the same strategy as we did on the other ones. So the ramping thingy. So to the counter, let's go that. In this case, since we are doing like a pattern of parts, I could actually do, let me do it on this one, since there are a lot of thingies to select. So we can do this, new operation, 2D milling, 2D counter. I'm gonna select just these two. The mill, I'm not sure which one it's my 2 millimeters. So I need to search 2 millimeters. So we have 12, 12, 12, 2 millimeters ball. Nope. What I want, it's this one. So no, this one is for steel. I should have one. Oh, it's here, 26, it's this one. So I want to select the finish. Again, so the heights, the top one, we're gonna select this one. No point of the bottom. We can use the selected contours. Let's make sure I'm gonna go under, so -0.2, and smoothing as usual. Multiple finish pass as well. Let's give it a 0.1 finish. Multiple depths we don't need. Stock to leave we don't need. So this doesn't matter. So we're gonna select the ramp. And we're gonna leave this for now and see if it works. We don't need it to go as high, so the start of the ramping. And the ramp step down, let's put something like 1 millimeter tops. And then we have this thingy, right? Everything looks good, but the problem is you only have for this one. So now we can actually right button it and create a pattern, and on the direction we select the X, the quantity, so we have 5. We can flip the direction, of course, and the spacing we have 34 since it was the 5. It was the spacing between the parts that we made. And now we have the same operation making on all of them. We could have done all of that this way, except the first one. But all the facings, and the rest, we could do it like that. We can do that for the chamfering as well. So now I could copy this pattern. I can duplicate it. And why I need to duplicate it? Because I'm going to use a different tool for the next thingy. So now I can do the chamfering. So now I'm going to create a new operation inside the pattern. Even if I create it outside, we can move it, drag it inside. That's fine. But create a new operation, 2D milling chamfer. So now we can chamfer this thingy. Again, it's just a cosmetic chamfer. So we're gonna do something like a 0.3 millimeter. I'm actually gonna use 3 millimeter chamfer tool for this operation, and I have no idea which number it is. So why do I have a 38? Okay, so it's the 40, doesn't matter. As for, I selected everything. So I'm gonna do like a 0.3 chamfer tip. I'm gonna keep this thing very close because we need to do this one. So like that, And now I can delete this one, because if I delete the one operation inside, if you only have one operation inside of the pattern, if you delete it, the pattern will go away. So this way, everything is chamfered. And we are pretty much almost done. So supposedly we would be done, right? We only need to flip this and deck the rest. But since we have so little here to hang out, it's going to be hard. Even if I use my well, if I use my 1 millimeter jaw, so we only grab 1 millimeter here, parallel, not jaw. It's going to be too little, so I'm going to use, I want to use as most as I can. So I'm going to use 2 millimeters. So I only have 1 millimeter. Then to chamfer this with only 1 millimeter, it can be dangerous. So what I can do actually is chamfer is like what we call back chamfering, which we use like a dovetail. I'm going to duplicate this thingy again. So I'm going to create a new operation, 2D milling, 2D counter, but for that you need to actually use your head to make the math. So I'm going to use dovetail. So I'm going to use this one, 6 millimeter, 45 degrees dovetail. So that tool is there exactly for this kind of stuff. And what I'm going to do, so I like to do, there's a few things I like to do with these tools. So first I'm going to select the bottom, of course, which is what we need to chamfer. And on the heights, I like to go a little under. So minus 0.1, because sometimes the tool doesn't actually end on the, where is my, yep, chamfer the bottom from the top. Exactly, that's what we're gonna do. So sometimes the chamfer tools don't actually finish on the, like a pointy edge. It has some kind of machining error. So I like to do a little under, but you have to keep in mind that if you go a little under, you need to go as well a little deeper on the chamfer. So now what we're gonna do, as it is, if we finish, let's activate smoothing, let's do nothing else. If we finish, we're not gonna get what we need. We can select the preferred lead-in positions. We only need one because we're only doing one. What it's gonna happen, it's not nothing it's gonna happen, because the thing it's gonna just run on the edge of the part. What we need to do is actually tell Fusion to, I usually do that on stock to leave. Well, we need to do on stock to leave. So on axial stuff, nothing. And here you're gonna put the negative of the chamfer that you want. So we want a 0.3 chamfer, but since we are going a little lower, like 0.1 lower, we need to go 0.1 deeper as well. So we need to go, if we want a 0.3, we need to actually put 0.4 in there. And now we have our little back chamfer. So next time we can't do that on this because the thingy doesn't get in there. But then on that side we can go with the chamfer, because we are not in danger of eating the vise anymore. So I'm going to delete this one again, so we can keep this. So now if I simulate this thingy, So we're gonna do the adaptive, we're gonna do the facing, we're gonna do the flooring, we're gonna do the walling, we're gonna do the outsiding, we're gonna do the slotting, we're gonna do the chamfering just a little bit. Let me hide the model like that, everything. And then we're gonna do the back chamfering. See? So now when we go the other side, like that, so let's create a new setup, like select the bodies, let's select the axis, so these should be the front, like that, that's fine. Model point, I'm gonna actually select that one, that little corner that I like. Everything else should be fine. Now we are holding up to 1 millimeter here on top. So now we can actually use the face mill, new operation. Fuck you. I have my hands are freezing. So we can do with the mill, the big mill. Where is it? Here. Multiple depths, 1 millimeter, finishing step 0.2. Use even, nothing too old. So right now the part's gonna be pretty much finished. Only we need to do is just do the chamfering of the slots here, which actually I'm gonna copy from here. So I'm gonna copy that pattern. I'm gonna edit well, no, not the pattern, because the pattern is the same. I'm gonna edit I'm gonna only select these guys. Everything else is fine, it's done. And we do that, it's gonna do the pattern. And now when we simulate everything, chamfering, back chamfering. See, it's cut already. And we just need to, let's move one back. Okay, so it doesn't regenerate the stock, so it does the, we just need to chamfer the little thingies. And yeah, it's done, and we don't need to reach this outside piece, getting chance of chamfering our vice jaws. And yeah, that's about it, and that's it for today. I'm gonna save it. I'm not gonna do the setup sheet, since I need to check the stock size. But yeah, so that's it for today. I hope you guys learned something. We pretty much finished the cam. There are a few more stuff that I can show you, not on this project, but on future projects with the actually using actually the Milo. But it covered a lot of the basics, pretty much all of the basics. I think I covered all of the basics on the on this series. More to come. Yeah, that's fine, Joseph. Just be safe. That's fine. It's doesn't matter. I'm good because the more you guys chat, I'm not complaining. You guys should chat. It's good to have interaction, but this way I actually do more. So if you guys have any questions, please comment. Join us on Discord. We have a server. It's pretty fine in there. Small community, very helpful. I answer everything I can. We're gonna learn more about this subject, and actually this is something that I'm pretty sure you guys, even if you watch the stream 10 times, seeing me doing all this stuff, when we actually do learn, it's actually machining, and we see the mistakes that, oh, okay, I did this programming this way and the machine doesn't quite like it. I'm not gonna get as much, I hope not, because I have already the experience of machining, and I already, when I design a part and when I'm programming a part, I'm already thinking how I'm gonna hold the part, and because it's the big problem of CNC machining. It's not actually most of the times it's not actually machining the part, it's actually grabbing or holding the part. So that's part of the problem. It's not like a 3D printer that the plastic sticks to the plate and you just build from nothing. CNC machining is exactly the contrary. You start from everything and you need to reduce it until you get what you want. And it has forces included in game, so sometimes parts fly. Don't ask me. It only happened me to one time, but it happened already. And it was actually because I forgot to torque the device. I only finger tightened it. But yeah, sometimes it happens. Sometimes mills break. Sometimes you fuck up. Sometimes, well, many times you fuck up. And yeah. And you guys gonna see when we actually put our hands in the machine, and then you will start understanding why I did some stuff my way and not other way. And I'm not saying I'm doing the right way all the times. Many times I machine the same part 10 times, and then when I'm looking at it, oh, why the fuck did I did it this way and not that way? It would be easier, less tool changes and whatsoever. And it happens, and sometimes I machined a bunch of them already. So yeah. Again, thank you for watching. I haven't talked about our sponsor, Lab 4450, but the guy is always there for me, so I don't even bother of removing the logo, even if he didn't told me, hey, I sponsored that series. The guy is awesome. Check them out. Link in the description. Again, we have a Discord server. If you have any questions, join us there. Just ask. Thank you for making me company, and that's the only reason I make these streams, and I hope you guys learned something. And that's it. See you guys next time, probably Monday or something. We're gonna get back to the Micron, and I have some stuff on my main job to do, so after I finish that, I'm gonna give it a little clean up on my main shop so I can set up for streaming there, so we can machine all these parts. And yeah, we're gonna go from there. Again, thank you for watching and have a nice time. Have a good night and see you guys next time. Bye bye.